Welcome back. So I asked some help to figure out what was the problem there. So apparently the bug happens because of this. I changed this variable name to target piece. Yeah, I thought that it's the location from, not location from, it's the target location where the piece wants to land. And I have to check if this target piece is none as well. So because this condition is good for white pieces, but it's not good for black pieces. Yeah. And then for that reason, I don't think that condition we are now putting the condition here. If target piece is not equal to none, is not equal to none, and the color is the same, and we continue. Otherwise, it's and let me run this for one time so that we see how things proceed. Okay, now the only pieces that I can move are knights for now. So I can try moving them different places. I can go out of turn, for example, but none of them work. It only works if I do the right move and if I do it with the right turn, white pieces. And I can do this, I can take over knight. Now for black pieces, I have only one knight, do that, and take over. So things are working and it's good for now. Now I have to do the same for other pieces. For example, for rook and bishop and queen. But then be able to test if queen moves and stuff, we need the pawn move anyway. That's why I'm gonna do the pawn move right now. And then, yeah, let's try the pawn move right now. And then we will go back to other ones later. Okay. So for pawn moves, I will put pawns on pawn. If forward. Now if j is equal to 6 or k, so if turn and j equal to 6 or not turn and j is equal to 1. So if the piece is white and it's in the second row, or if it's in the 7th row and the turn is black, we can do en passant. So find that, and then but we have to do this exactly when there are some things that are going to be repeated. So let me just paste. There is the color. So if the color is not turned, return. Basically, cannot. Yeah, the move for white turn, there should be only white pawns to be considered. And then, so allowed moves. Let's define what are the moves that are allowed. Okay. Okay, so first, I guess we have to check move separately because like each move has their own thing, their own law. Ali Faison, welcome to chat. Zig, yeah, it's a Zig programming language. I don't know what does the first phrase, the first word that you wrote mean. Woo, I don't know. Okay. So here I have to define possible moves. For the pawn, there is a normal move, which is just pawn's move is equal to bar equal to f if turn then it is to f32 0 and 1 else. Okay, so if it's white, it's -1, I guess. Else 1. Okay. Black pieces come down, so their y increases. White pieces go up, and their y decreases. Okay. And promotion. So exactly, if it's turn and it's the white turn, and j is equal to 7, or it's the black turn and j is equal to 0. Next, after there's 3, there's promotion, there's en passant, there's move, there's the first move. Sorry, here en passant is when okay, let's do en passant later. First move, sorry. Const first move. Is it the first move? It's the first move if it's 6, or this is okay, very good. We can do the promotion also later because we would have to change the board. So there are certain things with the pawn move. I think the pawn move should return some stuff. Probably if it's promotion, so for example, it has to return some state. Promotion happening, en passant happening. And then we can change the board as a result of the state of this move. Oh, we're not doing a move here. We are just checking if possible. Okay, okay. Okay, let's try first. How do I do it here? Calculate a new thing. And then I will check everything is in there. Target space. Target piece. There's a target piece there. It's not possible. Okay, I'm just gonna copy paste this part and then change whatever is written. So we have the move, we calculate the new j, and we skip those cases where new I and new j are not in the board, not referencing a board anywhere in the board. And then we check if the target piece is, if it's empty or not. The target piece has to be empty for normal move, and for if we're going to take with pawn, target piece has to be enemy. So we have two if conditions here. Okay, so first, if target color is turn, so if target color is if target piece is none, so we're not considering collision now. Let's do moving first. So for moving, the target piece should be none, basically. We don't get the target color. We don't care about this one. We only care if target piece is none. Not none, continue. If it's none, then you can do the move. And here, so the white pawn can be between, can have the values, like for J, it can be it cannot be 0 basically. None of them can be 0 because 0 they have to do promotion, right? Oh no, I have to check the promotions. Why there's error here? Okay, there's continue. So here it would be a return, I guess. Okay, and then so pawn moves should be only max moves. You add one. That's cool. Okay, let's see first if one moves are now possible. Okay, the knight moves are okay, but the pawn moves are not okay. I don't understand why. Okay, let's see. Okay, checking move. These are all knight moves, right? No, these are pawn moves. Six, one, six, six, three. I just realized the whole logic is based on a row and column, where I should put the column first. That's why I'm confused all the time about this thing. I don't know how did I do this. Sorry. Okay, now I have to fix this thing. Why this thing is inverse? I have to fix it somehow. But for now, I think so. That's my guess. My guess is that I have to -1. This 0, I believe, and this 1 is 0. Yeah, now it's okay. Okay, there is a good behavior in this, but then I mean, this thing is always annoying that I have to. So I and J are completely inverse. I guess. Yeah, it's because. Okay, so the first one, or the first bracket is for the rows. That's how I'm considering it. And the second one is for the column. That's why the second one becomes X and the first one becomes Y. We can fix that, but we would have to change everything. Like, I have to change the board, and then I have to change how it's drawn. The whole logic has to change. I can try to do it when I go offline again, I guess, because there will be a lot of work to do and lots of bugs. Maybe I can try to do it now and just be done with this for once. Let's see, what would happen to the draw function? Yeah, so I and J would just change place and things will be okay. For this one, this is cool. It's okay. Doesn't matter. For this one, there is the py. Yeah, selected x is y. Okay. Yeah, these things become fixed if I just change the board. Okay, let's try. 2, 3, 4, 5, 6, 7, 0. Okay. This is I and this is 1. Here, 0, 1, 2, 3, 4, 6, 7. And here there should be only 7. Okay. This is 6. And then this is J and I. Or, yeah. Because I is the rows. I can make this J. Okay. Very good. Now here, let's try the calculations. This is I, this is J. And then okay, let's first see that row is good now. Yeah, it's okay. It's just that now the moves are not gonna work because we have to fix the collision. We have to fix the check mouse. Yeah, here. Move piece, it shouldn't be Y. This is X. This is Y. And this is X. And this is Y. X. And then in the move piece also. So X, Y, or K here. And then we go to update possible moves. The helper. Here, this is I and this is J. I, J, and J. Okay, this should be 0. This is -1, and this is 0. If for knights, it doesn't matter. Hi, how are you doing? Welcome to the stream. Check on Isaiah. Check on Isaiah. Isaiah. Sorry if I'm pronouncing names really bad. Okay, now in draw function, I missed the select stuff here. Yeah, here this should be X and this should be Y. Okay, very good. Now everything seems to be okay. Okay, very good. Let's go to the helper. Right piece. Okay, the pawn moves. Very good. So now the first thing that we want to do is, if the proposed move is a normal move, or oh no, so I'm looking for all the possible moves. I'm not looking for the proposed move. So I have to create those possibilities that I can do a first move. First move. How do I add those things? Okay, I have to add a, from here, I will put if first move, then there are some code that has to be done. And here I will define const new move. Okay, they're making some. Alright, it's okay then. I thought they're gonna make some fight, but then they stopped. The new move is a c.move. No. New move. Okay. Is f32. Again, if turn. 2 and -2. Mustache. Yeah. Sorry. Okay. My birds are excited. So okay. So hi, Jan the Hunter. You're asking to give a feature overview. What do you mean by feature overview? You mean what we've done already or what we want to do, like as the features of the game? I'm not sure if I understand this correctly. Okay, so right now I did the night move. Night move is okay for now. It loads all the. So I have done some of the graphic stuff, like loading texture and stuff. It's just the logic of the moves that I need to do. And in the logic of the moves, there is the queen moves that needs to be done, rook moves needs to be done, bishop moves needs to be done. Knight moves are okay. There is nothing to do. Knight moves are okay. And then I'm doing the pawn moves right now, and king moves needs to be done. Like there's castling and stuff. There's a lot of stuff here. Eh. Hi, Peter Reza. Thank you. So yeah, so and for chess, there are some moves that are, for example, if it's the first move for the pawn, you can make you can go 2 squares forward with the pawn. So I'm now doing that one first move. Um, yeah, one square moves is done already. So I'm just completing all the rest. Can you run the exe? So okay, let me. I have to first do comment all of this, otherwise it will give me error. Okay, click the run. So this is the board that it loads, and it's a simple board. There is nothing extra. And here you can do pawn moves. Um, it respects the turn, and it only does the moves that are possible. So I refresh, I update all the possible moves after each successful move has been done. And then, yeah, knight moves are okay. Pawn takes is not possible yet, but yeah, mm, normal pawn moves are okay. No. So there are stuff that has to be done. There's a lot to be done. Yeah. So I'm gonna go back to the code. Mm-hmm. Okay, I will have to make them underline. Return. Okay, I think there should be okay. The block. Right. Okay, I think I have to do the other one. Do the other way around. So if it's more than 0, oops. If it's less than 8, okay. If it's 0, it's less than. Okay. And then I create target piece. I think instead of first move, we can just see if the pawn is on its initial position, then assume if the move more than one field from there. Yeah, that's what I'm doing. No? So, okay, let me see. What I'm doing right now is I am adding all the possible moves to some list, which is called the possible moves. And then, because if it's the first move, it is possible to have a 2-square move with the pawn, but uh, it's also possible to move with them one time as well. So I have to add all of that. Okay, but because pawns cannot go back, yeah, pawns cannot go back anymore. Because here the move is if the turn is true, then it's the white move, and for white move the only possible move that we will consider is if it goes up. It's negative because it's the you know the axes are in the graphics is exactly upside down. So in that sense, we don't even consider the moves for pawns that are like, for example, if it can go back or other stuff. It's naturally like only the right moves considered. And I cannot really generalize this thing more than this because, so for example, here, um, um, here when I'm adding the possible moves, uh, this move is one move in front of the pawn, but this one is two times in front of the pawn. Actually, I can. Yeah, I can generalize this. Okay, so let me do this. How do I do this thing? I can create an array list here. So var moves dot array list cmove init as city. I will expect allocator here, by the way. Um, or I can just do. I mean, this is too much. Like array list, we don't have to make it array list. It can be some array which is okay. So this will be a 4. So how many moves a pawn can do on maximum? Castling. Are there more special moves than castling? So there is en passant. Like I don't know if you do you know the en passant move in the en passant move in chess. There is en passant, and then if it's the first move of the pawn, it can move twice, like 2 squares. If it's not the first time, it can move only one square forward. So the pawn is a little bit, yeah, pawn is like king, a little bit crazy. So I mean crazy. I mean there is more stuff to do. Undefined, and then here, var move number. Weight, I guess, or u size equal to 0. And then what I do here, if it can be a first move, then I will add this to there. Can you drag around the window that opens? I can actually do it, but it doesn't show it on OBS. So for example, do you see the title bar for this editor? Like it doesn't show. You can see this title bar, but for some reason, the other window, which is the runtime thing for this application, the title bar is invisible. Like when I run this, you see the chessboard. You don't see the title bar, but I see the title bar. There is a title bar for it. It doesn't show through OBS. So yeah, I can drag around the window that opens. These are normal. I think there are minimum stuff that Raylib gives you. These are all in there, so it's. So let's go back to here. And this is the move. And then what I do, I will say, for example, move number should increase 1, and I will add moves. I have to do it before moves, move number, equal to move. Then I will check for the first move. If first move, I will do the same there. Oh, that's cool. Yeah, okay, very good. And then here, I don't need to do these things for now. All of this I will remove for now. And I will copy paste the thing that I have in here. In there. Moves. I will call it MV. Okay. We don't have move here now. Okay, cool. So now it should, so the first move should be also possible. So first let me show you, I can just grab the title bar. You don't see it, you will see the mouse in some, in the code area, I guess. But I can just completely move around the, oh, let me see. Oh no, okay. Oh, you don't, okay, now that I'm checking, you don't see that I can move the window. I think it's because I fixed the location of this window inside the where is it? Okay, can I now let you see if it's moving in the screen? No, I think maybe if I do this. Okay, now you can see the real window. So this is the real window that is being that Raylib gives me basically, and of course here I am doing I do a window capture basically, and that's what you see, and the window capture doesn't give you the title bar for some reason. It gives you for Z, so for example Z has the window capture and it's okay, it's cool. I mean the title bar in Z, it's okay, but the title bar in the Raylib thing, the application that I run, like the game test, that thing is not shown. So anyway, let's go back to the code, to this thing. Let's test if two moves are possible and see that it's possible. Can I do 3 move? No. Can I do 1 move? Yes. Now that I made a move, can I do 2 moves again? No. Okay. So it's okay. Works. It's now I have to define taking for these things. Taking, I mean, it's natural, it happens. As I have defined it in the code, I just need to say that there are 2 more possibilities for the pawn to attack. Do that. So taking, there are 2 moves. Const take moves. If turn, so this will be a 2 to a 32, right? I can just do first take move left. Okay, so take move left would be x would be -1. That's also -1. Left from point of view of left, right from the view of white player. Yes. Here -1, and for white player y has to decrease. For black player y has to increase. Here also -1. Okay. Take move right, take move left. And then, so these are only possible if there is an enemy piece in that location. So considered new, and here. So here I'm checking. So this is for the normal moves. Okay, this condition is wrong for the. Okay, there is a bug here. Let me show you. I believe I can just go forward right now. Yes. I can just take the enemy pawn just by moving forward, which is. And it's all because of this condition here. Target piece, if it's none, so how do we find out this thing? Either I would have to separate all the moves, or I add all the moves inside the array, and then when I go through them here, somehow I find out which one is taking and which one is not taking. The ones that are taking, their x is non-zero. I can do that. I can just say that MV0, if MV0 is 0, then target color should be should not be equal to turn. I mean, I should have some kind of condition like that. That seems okay, I guess. Let's try that, and then if there's something wrong, I'm gonna moves, and then move number, take left. Okay. And then it goes through all the moves here. So first, if target, okay, so it's not target color, if it MV0, if MV0 is 0 and target piece is not none. Continue. And then here, if MV0, so if MV0 is not equal to 0, and now target piece is none, or is equal to turn, but this thing is, okay, how do I, this is always true because for the black pieces, for taking, I have to make sure that the target piece is not none and is not the same color as the piece that we have. Oh, I can't just put here tempo bigger than 0. And so this means that this is true. For white pieces, okay, it's 0. Moves on 0. Then target piece be not empty. And the color should be exactly the opposite. Let me do this. if MV is not 0. Actually, I can just make it nested if. No? Okay. Else if target piece is none, continue. Okay. Okay, now here I don't need to care about target piece being none. I just care if I can actually add it here if target color is not, if it is turn, right? Continue. Okay, so here if move 0 is 0, that means that we are just moving in the ordinary column movement in the same column. So we just have to see if the target piece is empty. Continue. But it's not just the target piece. If the move is twice, then there's another thing that we have to check here. So if the absolute value is equal to 2, okay, I'm getting confused. So 2 moves are only possible if the 1 moves are possible. I can do that. So for example, if the 1 move is not possible, then the 2 movement shouldn't be considered. But then this means that I have to control which one comes first, which one is checked first, which one is not checked first. I cannot do it in a loop. It's going to be complicated. Okay, I don't find an easy way to do it like this with a loop. I guess I have to first move is possible. If the move is possible. So here I have to first check if move is possible. Then first move should otherwise first move should not be. Okay, that's the first thing. And the take are completely separate. How do we do that? We just move out all the things that I've written for the loop. I can make, so I will make this move 1. Okay. I can just keep the loop. I have an idea. Keep the loop, but put the conditions there. So can I do that? No. Yeah, I can try. Okay. Um and then there is the target piece. Calculate target color. Okay, let's go here. So here I define new j, new I, and new j. I give it move 1. I will consider this. Now continue doesn't mean anything. But variable 1 move. Like 1 move flag. Okay. Then we come here, we get the target piece. Here we don't need to consider new I. Okay. One move back. And then here, if one move flag, okay, add this. Oh yeah, okay, I have to check. Okay, I have the target piece. Okay, now here is the funny thing. So if the target piece is if target piece is not none, then one move flag is false again. Very good. If one move flag, if it's possible to make that move and add it. Now first move is that. First move and one move flag. First move, I will change this to okay. Then we add it to first move here, otherwise it's blocked and it cannot jump over the other piece in front of it. You think you could have only one check so you don't need black and white in all lines? Yeah, I mean, I think I could have, but I made things a little bit more complicated by adding, so here's my where is the here, so I have an enum piece and it's a U8, so basically it starts assigning values to each one of them. So 0 is for none, 1 is for white pawn, and it goes up to 12. So it would be I could just do, say, for example, after some value, so it's like 7, from 7 the black pieces start. So I could say that, for example, if it's over 6, then it's definitely a black piece. If it's under 7, it could be empty or white. So that's the confusion here. There is a possibility of emptiness. That's why I am, which makes me confused all the time. You could invert the index, like depending on the turn, you could invert the index. Yeah, that's what I'm doing basically. So here when I'm defining, where is the thing? Yeah, here. For example, turn if it's white, if it's true. If it's a black turn, it's false. Then the index just these things that are defined just depend on whose turn it is, and it's working. It's okay. There's nothing wrong with this, and it's okay. It's just that it becomes a bit more complicated when considering if you want to consider like a pawn move is possible, because there are multiple pawn moves and multiple places to consider for each pawn move. It's not the same rule as the movement for like some other pieces. It's a little bit different, the pawn move. Like it can be blocked, I have to check that and stuff like that. I could put I could make this step and then go by one by one, do that, or I could just do the thing that I'm doing here. Okay, now there is still a target piece that I have to do here. So what I'm going to do, I have to find them as a variable, I guess. And use them again in name definition. Okay, this should be constant. Then here, target P. And if it is not none, okay, I do all of that for one move black, and so it's okay here. Now I have to do similar stuff for first move black. So okay, one is not needed. Two times times one. Don't need that. Where is the first move flag? Okay. False. Target piece is defined. With the new I and the new J, then this one is first move flag false. If both of them are okay and true, then we can add the new thing. So this would be new I, and this would be new J. Okay, now the take ones. So for take, there are two things that must happen. For take, all of this is possible only if okay, so we'll need all of that. This is needed. All of this is needed. So take left. I plus exactly. Okay. J is that. Okay, here we have to consider new I as well. When did we do that? This is okay. Take, move, left, flag. I will add two flags here, I guess. Take, move, left, take, move, right, flag. Most of them are true. Okay. How are you checking the leaks? So the leaks are checked by where is my main.zig here? There's a general purpose allocator. I'm using that, and this allocator has a thing where when you finish the inits for the game and the initialize everything that you have allocated in the memory, you can call this GPA with the init, and it returns you some leak stuff, some information on the leak, and you can print that, and it's printing okay because there is no leak. But if there is a leak, it will exactly show me what is defined. And so, for example, game.init, if I just do it, but so there are some errors. I cannot compile it, but I will show it when I the code here. There's a lot of error. When I will finish this, and then I will show you how it shows the leakage. Take, move, left flag is false. And then I define the target piece. Now, okay. So what should happen is that target piece should have if target piece. I get the target color somewhere. Okay, here. You here. So this is var. So it checks if the target color is white. If the target color is turn, if it's not turn, and target color is not none. So basically it shouldn't be empty, and yeah, the turn shouldn't match the target color. Then okay, so if it's none, do I? Okay, this is the condition to continue, right? So mm, so you allocate for the whole function. Allocate for the whole function. What do you mean? How do I allocate function? Where is the okay? I mean, we send the allocator to different functions when we want to define things like like things that you want to have like dynamically allocate memory in the runtime, and you send the allocator to each function to allocate memory based on um, what you want to create there in the memory. I don't. I'm not sure if I can actually answer the question. So what if you don't even allocate? If you don't allocate, you cannot create. So it's like I don't know if you worked. Have you worked with C? So if you don't. So for example, in C, if you've seen it, if you don't allocate memory in the runtime, you cannot add stuff to your array. Like everything would be static. I don't know if you have, or if you want to. So this, I think it doesn't exist in C, but in here, when we want to create pointers, even we have to use the allocator. This way, in this way, we can use the allocator to keep track of the pointers that we have created and stuff like this. Arrays in C, yes, they are static, but if you want to create dynamic arrays and stuff, you use memory allocation. It's a similar pattern here in Zig as well, but creating pointers also you do use allocation. You use the allocator to create pointers and other stuff as well. Unless it's a reference, of course, the reference are different. But aren't array lists already dynamic? They are dynamic by allocate. There is no other mechanism. So the mechanism that allows array list to be dynamic is the allocator itself. So you have to pass the allocator. You choose the allocator and you pass it to the array list for them to function, basically. So for example, do I have array list here? I don't have. everything that I've defined is static here, I think, so I don't have array list to show you. But yeah, array lists are, you can actually check their definition, and it's an open source thing, Zig programming language. You can go check their code and array list. Okay, it's a standard library, this thing, array list, aligned T. And then you can see what is the array list. What is their definition and stuff. But yeah, there is no, so the dynamics of array list, so programming language doesn't have an extra, the standard library doesn't have extra stuff to enable you, like everything that exists in the programming language in Zig is exactly, um, uh, it's available for everybody, even in the standard libraries. There is no hidden mechanism. Okay, so all of this should be copied and pasted here. Okay, now I do the move right thing and then calculate these things and do right, right, right. These are right, tempo, I don't need to define it. Target color, I don't need to define it. This is right. If add, okay. For moves, okay. Here, paste, paste, paste. Okay, and I need these things. Do first move, then I do the first tick, left one, and I do the right one, and then I don't need this one. It's a very long one, but if it works, then it's okay. I guess there is maybe a way to make this simpler somehow, I don't know. But for now, I don't see how I can make this even simpler. Okay, so there are two things left, promotion and en passant. But let's see if this thing is working. Like I should be able to go twice. First move. Okay. It's new I. Part of the floating point value out of down. What? Oh, okay. Hmm. I used to do continue. Continue was better. Stop this before happening. But then here, even if I do this, the next step, the next line, I'm using the new I and new J. So, and if they go out of bound, then yeah, that's gonna give me error. Is the usize giving the largest integer for your machine? So I think yes. So usize is like the array. It's a special uh, thing for array index, and it's bigger than U64, I think. So U64 is, or maybe it's about the same. No, it's not the same size. I think usize is much bigger than 4. That's why. So U64 is like if you want to define a variable, but then the usize can be much bigger. But I have to make sure that this is correct, what I'm saying. I'm just gonna ask AI, is U64 bigger than U size in Zig? Well, I wrote it opposite, but it's gonna give me the right answer anyway. Okay, so U64 says that it's a fixed size, but U size is like a dynamic thing, and it can change depending on the platform. Okay, on a 64-bit system, U64 is 64 bits, U size is 64 bits. They are the same size. On a 32-bit system, U64 is 64 bits, but U size is 32 bits. So U64 is bigger than U size. U size is the unsigned integer guaranteed to be the same size as the pointer. It is used for memory addressing, array indexing, looping over the length of slice. So yeah, that's it. I think that answers the question. I think I'm gonna have to rewrite the pawn move again. So I'm gonna write a function that I'm gonna use with queen, rook, bishop, and probably king as well. This thing is annoying me right now. For some reason, I cannot make this thing. On move 2, move 1, move 2, move 3, move 4, and then I go to loop. I create the new things, and then I would put some stuff there. I guess I have to do the loop again. So I have this one. Move 1 is this. So the thing is that this is okay. Okay, let's do. Okay, fn check on forward. And then I would have to give the board. I mean, I don't like to do function for this. I guess I have to. Oh, I can do. So can I make a block here? Yeah, I'm gonna have to ask this one from AI. Can I make a block in Zig? Can I make a block labeled block in Zig? And whenever a condition is not satisfied, I just return or get out of the block, get out block by return okay or something. If it's possible to do this, then this should be right. So it says logic break. Okay, we say break logic. Okay, that's cool. So here, Vernom move through defined. Okay, I will put this block forward. One move. Okay. Break one move. Break one move. This is const. Very good. Okay. Okay. First move flag. Okay. Now here. This should be const. Okay. To move. Okay. If not this. Okay. Okay. Very good. To move. Break. To move. Break. To move. Four. One. Flag. Okay. That's okay. Changing. Flag. Only true. Go to the end. take left. Okay, we don't need these two. Const. Const. Okay, here we have to break out of this thing. And then target the const. This thing we have to get out of this thing. Okay, break out of the thing. Care about that. And then this is const. This is const as well. Okay, take right. Break. Break. Make them constant. These two are const. Okay. The end. Also break take right. Okay. Let's try. Okay, so I can move twice. I can move once. I move twice. I move once. I can take. We can take. Cannot do that. Cannot do that. I cannot go there. I cannot go there. I cannot go back. And so if I go here, you come here. Okay. Okay, so pawn moves are now working. I mean, it's quite crazy. Maybe there is a better way to do it because now I'm creating some blocks and I'm breaking out of things. So I don't know if this is a really good way of writing code. By it working, it's working. So it's been some time I've been writing. I'm just gonna be updating. I'm gonna update the GitHub page. Added some night and pawn movement. So for now this is okay. I'm gonna add promotion and en passant later. I just want to get out of the pawn moves for now for a while to breathe. But now it's possible to see um, if okay, now I can add bishop, rook, and queen moves. So let's start with rook moves. So how do they work? Again, there is a certain condition that has to be satisfied. Okay. This is a condition that has to be satisfied for all of them. So I can just for bishop, for queen, and the king. Okay. How do we do with the rooks? So I have to create some step, const, step. So steps. Two. Okay. And here 32 2 by 2 f32. That's 5 they do. Okay. And then here it's 1 0. So I actually go plus and minus. Okay, I guess better to do it like this because but now I can exchange the so 1 and 0. I can exchange them, no? But for bishop, it wouldn't work. And this is 0-1. So that's for white pieces, right? And for black pieces, oh, okay, it doesn't matter what's the piece color. It's always the same. These are the steps that we can take. -1, okay, very good. And this is 4. Very good. Now I want to write a loop step, and then I will do a step here. Okay. So for each step, we have to do a while. Var new I equal to I, and then var new j equal to j. Some while those are good conditions. New I, for example, is less than 8, and new I is bigger than 0, bigger than or equal to 0, and new j less than a, and new j bigger than or equal to 0. We are going to do okay. J, and then here new j, new I plus equal to 0, new j equal to this, but this has to happen at the end. Right? No, it has to happen at the beginning. Then we say, for example, we take the target piece, we check if target piece is less than 7, if target color is equal to turn, and target piece is not none, break. In other two cases, possible moves becomes this thing, and we add the M move. Okay, that's good. Moves. Okay, we're gonna do the same for okay, we're gonna do the same for First that was rook, then bishop moves same. But the steps are gonna be 1, 1. And then -1, 1, -1, -1, and finally 1, -1. Okay, very cool. Do all of this. Queen moves. Then, okay. Steps would be, so for a queen move, that's a rook move. The rook move for a queen move, we will have the rook moves plus the diagonal moves. So that's queen moves, rook moves, and bishop moves, knight moves, and some of the pawn moves, all of them. Let's see if they are correct. Happening. Oh yeah, okay. So queen moves, where is queen moves? Yeah, this is, the size is 8. Okay, there is some error somewhere. Okay, it says out of bounds. Oh, we don't check that. Okay, I see. Hmm. Okay. So I have to make this true if it's less than 0 or bigger than 8. Freak. Make this in all the loops here. Rook move, bishop move, bishop moves, rook moves, queen moves. Okay, so this is normal. I should be able to move the queen here. Yes. Okay. Bishop moves don't work for some reason. Oh no, it's a turn thing. Okay. And then there's a knight. Oh no. Okay. And then there should be a rook move. Yes. Very good. Yeah, it's working, all of it. Oh, I wanted to show you how leak happens. How does it report the leak? Forgot. I don't know if you're still in the chat, but anyway, I'm gonna do it so that it will exist in the video if you watch it later. So whatever I do, I run the code, and then at the end, it will show me leaks leak, and you can see that it's showing all the like memory address leaked. Here I'm creating chess. Where is it? It's inside the game init thing. Yes, it's in chess.zig, line number 41, line number 41 here. So this has been created. Basically, there has been memory allocation for chess struct, or created a pointer, and inside the init function, and this is leaking, so not manage that. So I just have to go back, and yeah, when I do the init thing, which I have defined in here, the init, and I destroy with the allocator the pointer that I've created from chess. And then when I do that, everything runs smoothly. There is no leak. So if I close this, leaks, okay. There is no leak. Okay, what do I do now? There is a bunch of stuff to do. There are two moves for pawn, and then there are king moves. So I can do the normal king moves and then go to the bigger ones, like the castle. So normal king moves are okay. Actually, king moves are also normal. King moves are also tricky because if the next if I'm close to the other king, I have to consider one square spacing between them and stuff like that. So there is some stuff to do here, and I'm gonna do them when I come back. I'm gonna have to go rest a little bit. I will be back in like 2 hours, 2 or 3 hours, probably at 19, around 19. So Paris time, of course. Right now it's 16:41 for those of you who want their reference. It would be like 2 or 3 hours later. And don't forget to subscribe and like the video if you haven't already. Thank you for watching and being around here. Let me just update the GitHub page for the code. Added rook, bishop, queen moves. Very good. Okay. Yeah, take care. I hope you have a good day or night, wherever you are. See you. Bye bye.